Composition of functions. How do we find composition of functions? For example, in this question we are given three different functions here. A function rule of f, g and h, and we have to find f of g of x. That's how we read it. Composition of functions. This is how we read as f of g of x. That's how we read it. This small 0 here, it must be smaller than the f and the g, and this is how we read it. Okay, so how do we actually evaluate it? Let's see. So you would take, I'm going to do the first problem over here, f of g of x. So f of g of x. So the first function here is f. I'm going to leave that f outside, and I'm going to put the g of x in square brackets here. Alright, so what I'm going to do is, this lesson is almost a continuation of the lesson called evaluate functions. So if you have questions on how to evaluate functions, watch that video first and then watch this one, which will make it easier. So we have to take the f rule. The f function rule is the first one over here, which says 2x plus 3. So in the f function rule, instead of x, I'm going to plug in the expression for g of x. Now we know g of x is x squared minus 4. So instead of g of x, I'm going to plug in x squared minus 4 in the place of x in the f function. So I'm going to keep the f here. I'm going to treat it like f of a giant x over here. That's how I'm going to think. Okay, so f of x. So instead of x, I have to plug in the rule for g of x. So that's what I did here. And then we simplify. We distribute the 2, which is 2x squared. We distribute the 2 in here to the negative 4, which is negative 8, plus 3. And as we combine, we know that negative 8 plus 3 is negative 5. So 2x squared minus 5 is the answer for f of g of x. Only other question that they can ask of the same kind of problem is they could ask you to evaluate f of g of, let's say, 3. Instead of x, they could give you a number for that composition. So there are two ways to do it. One way is find out what is f of g of x first, and you get this expression right here. Yeah, you got 2x squared minus 5, and in the place of x we can just plug in 3. 2 times 3 the whole square minus 5. So we get our answer as 2 times 3 square is 9 minus 5. 9 times 2 is 18. Take away 5 is 13. So that it can be done that way. Or let me clear this left side. Or the same problem can be done. The question is f of g of x, g of 3, right? So we keep f is the first function, we keep it, and then we put g of 3 in parentheses like that. And then in the rule for f, okay, we're going to evaluate g of 3 first, sorry. And then we're going to evaluate g of 3 first. G of 3 is, what is g of 3? In the place of x, we are going to plug in 3. So here, instead in the place of x, we're going to plug in 3. So that will be 3 squared minus 4, which is 9 minus 4, right? Which is 5. So we're going to put g of 3 as 5 over here. So in other words, we're going to find out f of 5, right? I'm following from this step over here. This step becomes f of 5 because g of 3, we evaluated g of 3 to be 5. So f of 5 will be 2 times 5, 10, plus 3, which is 13. So we got the same answer, and those are just two different ways to do the same problem. So let me clear this and let's try to do another one. So we already did the first one. let's try to do the second problem. G of f of x. G of f of x. So how we do that is we keep the g, the first function stays, and then we put the parenthesis, and then we write f of x in it. And then in the rule of g, we're looking at the first function g. In the rule of g, we are going to change the x. Instead of x, we're going to substitute f of x. So the rule for g says x square minus 4. That's what the rule for g says, right? In this rule, instead of x, we're going to plug in f of x. What do we have for f of x? It's 2x plus 3. So we write 2x plus 3 the whole square minus 4. So now we have to multiply 2x plus 3 times 2x plus 3, because 2x plus 3 the whole square just means you're multiplying 2x plus 3 twice. I'm just going to explain the steps here really quick on how to multiply. If you know it, you can just forward it. So we distribute the 2x here. 2 times 2 is 4x square. Distribute the 2x to the last term. 2 times 3 is 6x. Now we distribute this positive 3 here. 3 times 2 is 6x, and then to the second term, 3 times 3 is 9. And then we combine like terms, so we get 4x square. 6x plus 6x is 12x plus 9. So that's what we get for 2x plus 3 the whole square. We get 4x square plus 12x plus 9 minus 4, bring down the minus 4. And then simplify. Like terms combine like terms, so we get 4x square plus 12x plus 5. 9 minus 4 is 5, and that's our answer to that question. Now let's try to do the third one. We have h of, we write that O a little more smaller. So h of g of x. So we keep the h and we put the g of x in big parentheses, square brackets over there. That's just an easy way to see. There's so many different ways to do this, to think about it, to start with, or to explain the steps. This is just one of the ways that I'm following right now. So h, in the rule for h, I'm going to replace the x with g of x. So I'm looking at h. This is my h rule here. H says if I have x, what should I do with it? I have to do x minus 2. So instead of x, I have, let me type it over here. Instead of x, I have g of x now. Now g of x is x square minus 4. So I'm going to do x square minus 4, and minus 2 is minus 6, and that's my answer. Last question, let me clear this. F of h of x. Remember, they will give you questions. They might always give you different functions. You have to make sure you're choosing the correct functions. We are dealing with f and h here. We do not have to use g in this problem. So f of h of x. So I'm going to write h of x here. So in the rule for f, so I'm going to write the rule for f here. I'm going to start with f, right? 2 times x plus 3. But instead of x, I'm going to plug in h of x. And h of x is x minus 2. So we get, let's distribute 2 inside since it's parentheses over there. 2 times x minus 2 times 2, negative 2 is negative 4 plus 3. When we combine like terms, we get 2x minus 1. So the only other questions that may arise in this situation is you might have, instead of x here always, you might have numbers. We did one of the problems before. Let me give you one more example. What if you had to do f of h of negative 6? What if we had to evaluate that? So one way to do that is, you would first find f of h of x, get the expression for it, like 2x minus 1, and then instead of x, you plug in negative 6. So you would get 2 times negative 6 minus 1, and 2 times negative 6 is negative 12 minus 1, your answer would be negative 13 in that case, right? Or you can do it another way. You would first find f, you would write it like h of negative 6 first, and then you would actually find the value of h of negative 6 first. H of negative 6, I already did that here for you. H of negative 6 is negative 6 minus 2, which is negative 8. So I can find f of negative 8, and f of negative 8 would be, instead of x, I plug in negative 8. So I get 2 times negative 8 plus 3, 2 times negative 8 plus 3, 2 times negative 8 is negative 16, plus 3 would be negative 13. I get the same answer. The only other type that we have, that we may get a question that might arise, is when you combine, is it possible to combine 3 functions together to find the composition of 3 functions? So there could be questions like f of g of h. You would have to evaluate a function like that. So all we have to do here is take it one step at a time. So I'm going to do f. Inside the f function I have the g. Inside the g function I have the h of x. So this is how I would write it. F of g of h. Okay, it's like a layer. So I'm going to first substitute for h of x here. Instead of h of x, what do I have? We have the expression x minus 2, so I'm going to put x minus 2. So that's what I have first. It's the first step. I replace the h of x with the expression that went with it. Now, f of g of x minus 2. Now I'm looking at the rule for g. This is the rule for g, right? So instead of x, I'm going to put x minus 2 there in this expression. So I get x minus 2 the whole square minus 4. So what I do is, to make things simple, this expression x minus 2 the whole square minus 4, I'm going to simplify it. We already know that x minus 2 the whole square is x minus 2 times x minus 2. So when we distribute and combine like terms, we get x square minus 4x plus 4. That was the answer. I did that in one of the problems before. So here x minus 2 the whole square is x square minus 4x plus 4, and then this last negative 4 comes at the end. So they cancel and we get our expression as x square minus 4x. So I'm going to write my simplified version here of this. The answer is x square minus 4x. Now I'm going to take this new expression that I got for from simplifying g of x minus 2. I'm going to take this and I'm going to put it in the f rule. So the f rule says that f of x is 2x plus 3, right? Instead of this x, I'm going to substitute this whole expression. So 2x plus 3. So I'm going to substitute this expression there. X square minus 4x. Now since it's parenthesis, we have to distribute. So 2 times x square is 2x square. 2 times negative 4x is negative 8x. And then we have 3 at the end. Since there are no like terms here, I cannot combine anything. This is my answer to the expression f of to the function, composition of function f of g of h. F of g of h of x is equal to 2x square minus 8x plus 3. And again, they can give you a number in the place of x. They could ask you to find f of g of h of 1. All you have to do is, in this expression, plug in x as 1 and you get your answer as 2 times 1 square is 2, negative 8 times 1 is negative 8, plus 3, so you get negative 6 plus 3 is negative 3 as your final answer.